Super excited to be here today. My second time at DevOps Days Charlotte. Let's start back in 1945. It hardly seemed like a revolution when it happened, but it certainly was. Oh boy, was it. In 1945, W. Edwards Deming started advising Japanese manufacturing companies to find and fix defects at the beginning of their production processes. Within 5 years, organizations like Mitsubishi and Toyota had become his disciples. By 1960, the total quality management principles that he espoused had become an intrinsic part of Japanese culture on their way to global manufacturing dominance. These same principles were applied in the United States by Ford Motor Company starting in 1981, and 6 years later, they had become the most profitable U.S. automaker. In today's high-velocity manufacturing processes in every industry around the world, focusing on Six Sigma goals, the defect rate goals for those organizations are 3.4 parts per million. It was therefore no surprise in 2010 when Jez Humble and Dave Farley wrote their seminal book, Continuous Delivery. If you haven't read it, you should read it. When they wrote this book, one of the key phrases that they used, I think in chapter 1, was build quality in. There was no mistake on why they put that in there, because they understood, like Deming, if you're going to move fast, you have to remove the defects from the system. If you're going to chase John Osbaugh's 2009 10 deploys a day, quality had to be built in. It was also no surprise 3 years later when Gene Kim published the Phoenix Project. And in the Phoenix Project introduced us to the 3 ways of DevOps. The first way, if you remember, is to emphasize the performance of the entire system, end to end, and to never pass a defect downstream. The third way, as you'll remember, was also to build an organization of continuous innovation and continuous learning. But it was these learnings about move fast and build quality in that are paramount to all of our success within DevOps. So I'm going to share with you today some data that no one, even at my own company, has seen. On Monday of this week, we closed the DevSecOps community survey for 2019. We surveyed over 5,500 people across the DevOps and IT software development industry. And I'm going to share some of that data today. One of the key data points that we saw is that the velocity, the dream of chasing velocity, 10 deploys a day, or multiple deploys a day, multiple deploys a week. 47% of the survey respondents said, we are deploying changes to production multiple times a week. Velocity has been achieved. But we've forgotten something along the way. You see, the reality is that just yesterday, I read since May 2018, the European Union has been notified of 59,000 data breaches under GDPR. The data breaches occur in our applications of people attacking our applications and people wanting to steal the data or take control of those applications that we are building. There is a crack in the system. That crack in the system is related to something that every single person in this room, in a software development organization, every single person globally in a software development organization relies upon. And that is a software supply chain. Every one of your organizations now uses open source components that are downloaded from the internet for free to accelerate your development practices, and it's working in spades. You rely on suppliers outside of your business that are building pieces of code as open source projects. They are putting them up on internet-based repositories like Maven Central, npmjs.org, python.pypy.org, Docker Hub, etc. And you are consuming those as a software development manufacturer. You are taking those free parts of code that you don't develop yourself, putting them into your applications, and shipping those to your customers. To give you an idea of this isn't something new, how big this environment is and how much you rely on it, let's take a look at the ecosystem of the suppliers. In the different development ecosystems, there are millions of parts available to you, and tens or hundreds of versions of those parts available. In fact, the demand is so insatiable for these parts that over 15,000 new versions are released every day to provide better functionality, better integration, better performance for the applications that you're building, where you're relying on the expertise of others. And it's not just the supply that's growing. The demand is growing exponentially. Each year for the last 5 years, I've championed a report called the State of the Software Supply Chain. This is data from that report, some of which for 2019, the report gets released in June, hasn't even been shared publicly, so you're the first to see it. And 10 years ago, 10 million Java developers were downloading 1 billion open source components from Maven Central. 10 years later, that same population of developers has consumed 146 billion download requests from Maven Central. If you don't think you're using open source, you are fully kidding yourself, and you have been for probably 8 years. And you're like, hey, cool, I don't develop in Java, I'm a JavaScript developer. Okay, so Lori Voss, one of the executives at NPM, tweeted out in October, in the past week, 6 million JavaScript developers on the planet have downloaded and consumed 7 billion JavaScript packages. If you don't think you're using open source components in your applications, you're kidding yourself. All the developers know this. If you're not a developer, you might not be aware of it. But the end result is that 85% of the average application that you are developing today is composed of parts that came from these third-party suppliers, from these external sources. And again, the benefit of this to us in the DevOps and software development community is that we are able to move faster than ever by standing on the shoulders of others. So none of your organizations is actually like downloading 1 billion parts or 100 million. The most I've seen is an organization downloading 16 million Java open source components in a single year. But the average organization is pulling in 170,000 Java open source components a year into their organization. These parts are coming from 3,500 different external suppliers. If you're a JavaScript developer, the stats that I mentioned before translate to every JavaScript developer on staff that you have is downloading 60,000 JavaScript packages annually into your organization, every single one of them. But we all know, in every manufacturing process and practice, in every industry on the planet, not all parts are created equal. Open source components that were developed 6 years ago and have 500 newer versions of that component, the newest one is better. It's got more functionality, it's less buggy, it's easier to integrate and use, right? There's a reason why new versions come out. But on occasion, those versions have known security vulnerabilities. When I stood on stage at DevOps Days Charlotte 2 years ago, I reported that of the Java open source downloads we had seen that year, 1 in 18 had a known security vulnerability on the day that they were downloaded. And we were ingesting that into the software applications that we were all building. So, what's changed since I was on stage 2 years ago? 1 in 10 Java open source components being downloaded in 2018 had a known security vulnerability in it the day that it was downloaded. If you think that you're doing the 3 ways of DevOps, that you're building quality in, that you understand your software supply chain and the end-to-end performance of the entire system, that you're listening to what Jez Humble and Dave Farley and Gene Kim espoused, you're not paying attention to this part. Because 1 in 10 things that we're consuming has a vulnerability. In Six Sigma manufacturing, they're only allowed 3.4 out of 1 million. We're far from high quality, high velocity manufacturing processes. And crap. You know what happened in October? Lori Voss over at NPM said, JavaScript packages have vulnerabilities too. 51% of the JavaScript packages that they analyzed from downloads in October had known security vulnerabilities in them. How many of you are doing JavaScript development? You think you don't have security vulnerabilities in what you're downloading? I'm just presenting the data. So if you're a Java, I don't have a slide. It's black. Okay, get the slide back. So if you're a Java development shop, this means those 170,000 components you're downloading annually, based on the 2017 or 2018 software supply chain report that I champion, 11% of those components, or 18,000 brought into the organization each year, had a known security vulnerability. Based on that NPM data, every developer in your organization developing in JavaScript is bringing 30,000 known vulnerable JavaScript packages into your organization every year, every single one of them, on average. 6 million people a year. So why does this happen? Well, there was a study, a lot of studies done after the Space Shuttle Challenger explosion about the O-rings and how much of the flames were coming up from the booster rockets on the launch pad, and that it was eroding the O-rings just a little bit, but nothing happened every time that they tested it. Nothing happened so often that when people were warning, hey, the flames are going a little higher than they should, people were like, yeah, but nothing happened. That's okay. The danger is there, but it's okay. Like, it's normal. Like, nothing happened, right? Don't need to pay attention to this. This is called the social normalization of deviance. You do something so often, so frequently, that this behavior just becomes normal commonplace. This is what we've accepted as normal commonplace within our organizations. And do you want to see the result of bringing known vulnerable open source components into your organization? In 2014, everyone remembers, if you were doing software development anywhere, Heartbleed, April 2014, right? Everyone remembers the Poodle and Bash and all the other, logoed bugs after that. And everyone in this room surely knows that in March 2017, or perhaps if you were just paying attention to the news, September 2017, Equifax was breached with an open source component, with a vulnerable open source component. So when we ask people in the DevSecOps community survey, year after year, for 5 years we've been tracking this. In 2014, when I asked the question, during the month of April when we were running the survey, when Heartbleed coincidentally came out, have you had or do you suspect a breach in your organization related to an open source component? We found 14% of organizations said yes. In 2019, the survey that just closed Monday, we're publishing the survey a month from now, 1 in 4 said that they were breached due to a vulnerable open source component in their environment. So this is a challenge for us. But it's not just about using poor quality code or defective code in your high velocity manufacturing processes. You have another challenge. That is, in the last 10 years or so, the time between a vulnerability being announced and the exploits appearing in the wild used to be 45 days. That has compressed by 93% over the last decade to 3 days. If there is a vulnerability announced, you have 3 days to respond to this. Do you want to see how this plays out in action? We'll go back to March 2017. It was March 7th of 2017 that the Apache Struts project announced that there was a critical vulnerability in its code. That same day, they released a perfectly safe version of Struts that remediated that vulnerability and made it available to anyone using Struts within their environments. The very next day, the NSA noticed nation-state scanning the Pentagon's networks for Struts vulnerabilities. The very next day after that, Cisco notices exploits being performed in the wild across networks that it's managing. On the third day after that vulnerability was announced, Equifax was breached initially, but they were not alone. Canada Statistics, Canada Revenue Agency, the GMO Payment Gateway. 3 days after this, Okinawa Power, Japan Post. A month later, India Post. A year after this, India's Social Security Identification Digital System breached by a Struts vulnerability, the same vulnerability that we all heard about in Equifax. Equifax wasn't announced until September. The breach happened in March because they didn't even know that they had been breached at the time. And today, 65% of the Fortune Global 100 are still downloading vulnerable versions of Struts into their software development practices. All in all, we can measure over 18,000 organizations globally doing the same thing. So when there is a vulnerability announced in an open source component, what do you do? It's very simple. There are two things that you do immediately. You ask, did we ever use that open source component? And the next question you ask is, if the first answer was yes, where in the heck is it? There is a very simple way to identify this, and it's used in every manufacturing industry around the world, and that is you produce a bill of materials. What parts are in this product that we just made? Right? In software, this is called an SBOM, a software bill of materials. In the survey that we just closed, we ask organizations to identify themselves as a mature DevOps practice or not a mature DevOps practice in different categories. But when the no DevOps practices answered, 19% of them kept a full bill of materials for every component and every dependency used in all of their applications. In DevOps practices, mature DevOps practices, 50% of them. This means 50% of those organizations can answer, did we ever use that component and where is it? Because you kept track of it in the life of that software. So in the DevOps community, we have an opportunity. And that opportunity is to automate faster than evil. How can we apply the practices that we know to be able to say, I've seen a defect out there. That defect happens to be a security vulnerability. And I can move a change into production in under 3 days because that's the adversary attack or exploit window that you have to move faster. If you can't deploy to production in under 3 days a new business requirement, you are at risk in your organization. The adversaries are using the same automation that you are to exploit your environments at large scale. And if you're thinking, crap, 3 days? Like we're not there yet? It got worse. In 2018, in our software supply chain report, we noted 11 occurrences of hackers, adversaries that took a very different approach. They weren't waiting for the Struts vulnerability to get announced, then looking for an exploit on ExploitDB or some other source, and then start attacking. They said, you know, open source components are used in massive quantities across hundreds of thousands of development organizations worldwide, and if I can hack into one of those open source projects, if I can steal the credentials of one of these project maintainers, or in fact, in October or November, someone handed over the event stream NPM package credentials to an adversary who injected malicious code into that component, and I think 200,000 times in the month of November, that component was downloaded into the software supply chains or through the software supply chains of your organizations. I talked to 2 people at random this morning that were like, yeah, we had event stream in our environment, right? And we needed to know that we were tracking and tracing that, or did we even use that component? They are not waiting for the exploit. They're actually crafting them by injecting malicious code into the start of the software supply chain that you are feeding on and creating 0 days themselves. They can monitor exactly when it hits the production environment and begin exploiting it immediately. You no longer have 3 days. If you are not paying attention to what you're putting in your software, the adversaries know this and they are exploiting this. Homebrew, some guy just decided, I want to see if I can get into Homebrew. He wasn't an adversary. It took him 30 minutes to have commit access into Homebrew where he could have done whatever he wanted. It's not hard. Imagine a nation state where you have employed 3,000 people to do this on a regular basis. Think about the scale of this. So what can we do? When we ask in the survey, are you building security practices into your software delivery lifecycle? Mature DevOps organizations far outweighed. The no DevOps practices are the yellow bars. Those with the purple bars are the mature DevOps practices. Across the development lifecycle, mature DevOps organizations are deploying automated security practices 350% more often than non-mature DevOps practices. It is possible. Organizations are doing this. This is, again, survey data of what we just closed with the DevSecOps community survey. We also ask, what are you using? And the most common tools in this one, sorry I changed the colors, but the mature practices are the green bars, WAFs, web application firewalls, container security, open source governance, static analysis, the top tools that are being applied for automated security across the development life cycles to keep up with the adversarial attacks and to prove that we can get quality into our software development processes. So with all of this, so we have defects, we have quality issues, we have adversaries, we have automation, we have tools. Are they working? The interesting thing that we ask in this survey, and we've asked it for many years, is one of the questions is, do you have an open source policy in your organization? Yes or no? If you answer yes, we ask you a follow-on question. Do you follow it? In non-mature DevOps practices, 25% of software developers taking the survey, again, 5,500 people, said, we have a policy and we follow it. We know what we're putting in, we follow the rules about what we can put in, and there are quality standards that we abide by. But in mature practices, 62% had a policy and abided by it. And you know why? Because automation is hard to ignore. When you surface intelligence and information to a developer and you're like, hey, that code that just hit the GitHub repo has a component in it that has a known vulnerability, and you shouldn't have that in your code, and maybe there's an alternative version, safer version, newer version that you can use, like, well, that's easy. What version do I go to, right? What version do I move to? When you present when you use automation to present this information, it's hard to ignore. So automation is not only relevant, it's actually working within these organizations. It's measurably working within organizations. In the 2018 State of the Software Supply Chain report, we analyzed over 60,000 applications, some within a managed software supply chain and some in a non-managed software supply chain. We saw in the report that the downloads at that time were 12% of components had known vulnerabilities being downloaded, but that doesn't mean they ended up in the applications. In unmanaged software supply chains, we saw 11.7% of components with known vulnerabilities, meaning they were flowing from one side of the software supply chain, ingestion, to the end inside the applications. But in managed software supply chains, they were able to reduce the defect rate by almost 50%. By caring, we know what we're putting in. We know the parts that we're putting in. We're tracking whether they have defects. We're tracking whether they have security vulnerabilities. And we're picking better parts and better versions of parts from better suppliers in our ecosystem, in our software supply chain. So you can listen to me espouse, here's all of this data about what's going on. And you can believe it or not believe it. You can choose to do something about it in your organization. You can choose to pay attention when the problem is not just beginning, it's already massive, and it's been massive for a long time. If you don't pay attention, this is where liability comes in. It is absolutely illegal in any manufacturing industry on the planet to take known defective parts, put them into a product, and ship it to consumers. You cannot put a known defective Takata airbag in a Toyota car and ship it to me as a consumer. That is illegal. It is not illegal in software. So what's happening? I've been looking and tracking at the software development policies, practices, and regulations that have come out over the last 5 years. 5 years ago, the Open Web Application Security Project, OWASP, put in its top 10 list, you can't develop software with open source components that are known vulnerable. Duh, like, why would you do that, right? But if you don't know OWASP, which my mom doesn't know OWASP, and many of you might not know OWASP, you weren't paying attention. But then 18F, the Department of Defense, the White House, the European Union, FSISEC, the FDA, the UK government, the German government, the French government, over the years have all introduced policies saying you can't put known defective parts, software parts, into your products and ship them to consumers. And you need to have a software bill of materials to track and trace these parts. The FDA is mandating medical device manufacturers identify what parts are in their software, and if there are known defective parts, you better fix them before this product ships to market. And when it's in market, if it becomes known defective or known vulnerable, you better fix it within a specific period of time, or we're going to hold you liable. So, you have a choice. You can go back to your offices and do what you're normally doing, or you can start your own revolution. You can listen to Deming. You can listen to Jez Humble and Dave Farley. You can listen to Gene Kim and think about building quality in, thinking about fixing defects at the beginning of your manufacturing process of software rather than letting those defects flow through the environment. If you want a copy of these slides or the Software Supply Chain Report or DevSecOps Community Survey, my out-of-office message is on today. If you email me, you don't have to say thank you or put in a subject line even. It will come back with an out-of-office message. The link to the slides are there on SlideShare. You don't need to register for them or anything. I've made them easily accessible to you. I thank you very much for your time, and I look forward to talking with you all in the hallway after. Thank you very much.